All right, I'm Lamar Smith. I'm a retired range management professor from the University of Arizona. And we're up here today on the Empire Ranch near Sonoyta, historic ranch in this area, now managed by the BLM. Anybody that's been involved in land management or ranching knows that not all kinds of land have the same capability. They produce different kinds of vegetation, they have different soils, they may be more or less stable, and so there are a lot of differences that are expressed in a pattern across the landscape. We see this pattern usually repeating itself, and gradually this concept became the basis for classifying what we refer to as ecological sites. So what we're going to really talk about today on the ecological sites is, first of all, talk a little bit about how these different areas evolved, what caused them to be different, and how we use that kind of information then to classify them into different kinds of sites. And then we'll talk some about the dynamics of the vegetation on an individual site, what the disturbances or management effects that might cause it to change. How do we use that as a basis for our monitoring, our management planning, for evaluation of what our management is doing to the land, and how we get changes from one type of vegetation to another, and finally end up with a few practical things about how we can use soil surveys or some of our new technology in identifying what site we're on or finding information about that site. Okay, the Natural Resources Conservation Service has mapped, or has identified and mapped for the whole United States what they call major land resource areas. And these are kind of broad ecological regions, if you want to call them that, of similar types of vegetation and topography and climate. They're the basic determinants of the site, but this is at a broader level. Arizona has 6 or 7 major land resource areas. We're right now here in southeastern Arizona, what they call southeastern Arizona Basin and Range area. And you can see the topography here. It's characterized throughout this area by these isolated mountain ranges with a big alluvial basin in between them. They delineate several precipitation zones, or zones based mainly on precipitation, starting with the lower elevations where you have 12 to 16 or 10 to 12, 8 to 12 inches of precip, and then that's mainly your desert shrub type. Then the next zone up is 12 to 16, that's mainly your grassland type, and then the 16 to 20 is your woodland type. And so within each of those, we describe the ecological sites based on other differences in soil, topography, whether it's down in a draw and get some extra moisture, or if it's up on the ridge, how steep the slope is, and what kind of parent material perhaps. We have limestone hills and granitic hills and so on. All right, we want to think a little bit about how these differences in vegetation and soils arise, because they're the basis for classifying ecological sites. Now, the area we're standing on here, we're here at about probably 4,000 feet elevation, and this area would get somewhere around 14 or 15 inches of annual rainfall, probably on the average. So that's one of the main things that determines what kind of vegetation is going to be here, is the temperature and the rainfall and the pattern of the rainfall. Arizona, we primarily get our summer rain in the late summer, and then we may get some winter rain. Then, if we're lucky, that grows some of the cool season grasses. But most of our grasses most of our plants make most of their growth in the summer, in July, August, September. And the area we're actually standing on here is composed of alluvial material that washed down in ages past from those mountain ranges. It was deposited here as a big bahada or alluvial fan maybe 1,000,000 years ago. And through the ages, that has been dissected by erosion, and the areas that were fairly stable were weathered into clay soils. Then some of those soils were eroded away and left this kind of alluvium that we're standing on here. There may have been a soil on this surface at one time, but it's all been eroded away now this is natural geologic erosion. It doesn't have anything to do with people. You can see it here on the road, composed of gravels, and those are mixed gravels. You'll see some are light colored, some of them have some limestone in them, some of them are volcanic, maybe some of them are granitic. So there's a mixed parent material here for soil to form on. The soil that's currently here has not formed very much. In other words, it's not been exposed to weathering on this particular spot for very long. It may be several hundred or several thousand years, but that's not very long in the age of developing a soil. So what we find here on this area is relatively limited amount of soil development. We've got a little bit of organic matter in the surface because it tends to be a grassy site, but no clay B horizon, no restrictive rooting caliche layers underneath it. It's classified as a Limey Slopes ecological site in the 12 to 16 inch precipitation zone. Limey Slopes is called limey because it is limey on the surface. Here I can show you what I mean. If we take a little bit of acid, this is some dilute hydrochloric acid, drip it on that surface. You can see the fizzing. That's the acid reacting with the calcium carbonate in the soil. That's one reason we carry this little bottle of acid, is to check that kind of thing out. That influences the kind of plants that grow here and the kind of production we get. It doesn't tend to have as good a moisture holding capacity as some of the soils that have more clay in the subsoil, but it does take in water pretty well. Some plants don't seem to like to grow on this limey site, and others seem to thrive on it. And some grow on either one. Cytosgramma, for instance, is here. It grows on here, it grows on the non-limey sites. It doesn't seem to care. Black grama is more common on this site than it is on the non-limey sites. False mesquite is another one that's very common on this site. And white thorn. Not many plants are restricted to limey sites. A few are, but some of them tend to thrive better on the limey site than others do. And I don't know exactly why. It may have to do with moisture relationships, and it may have to do with the soil chemistry. High levels of calcium carbonate usually make phosphorus, iron, zinc, and some other elements relatively unavailable to the plants, so that it may be that some plants can extract those elements, essential elements, from the soil better than others can. Another interesting thing about these limey sites is that the cattle don't seem to like to graze on them as well as they do on the non-limey sites. Again, I don't know why, whether it's the species of plants that are here or some of the chemical composition that affects the flavor of them. Anyway, this is what we would call a Limey Slopes ecological site. It's called slopes because most of it has a slope of 15% or greater. Just standing here so we don't fall off. Over across the way, we see something different. It has a reddish tinge to it. That is some of the volcanic rocks that are starting to be exposed by this erosion. They were covered up with the alluvial fan. Now the erosion is exposing them again, and we have a completely different ecological site over there. That would be a volcanic hills ecological site. Again, same precipitation, same climate, but we have a volcanic bedrock that the soil is developing from. The soils are fairly recent because it hasn't been exposed that long, several thousand years perhaps, but that's not long for a soil. So the soil tends to be fairly shallow, a lot of rocks on the surface. Different kinds of plants grow over there. Different species of shrubs. A lot of ocotillo grows on that site. It has a completely different potential. Now around in here, there's a very complex mixture of these two sites. So this would be mapped on a soils map probably as a complex of two different soils, one derived from volcanic rocks and the other derived from this calcareous alluvium. And it's two different ecological sites. That's what's called a complex mapping unit, because there's, at a reasonable scale of mapping, it would be difficult to delineate the individual pieces of it. So it may say Limey slopes 40%, volcanic hills 40%, and the other 10% is some inclusions of other sites yet, maybe some loamy bottom site or some other type that's in here in very small amounts. One of the things we see here on a site like this is that there's quite a difference between what we see on this limey slopes on the north slope as compared to the south slope. And that's due mainly just to the temperature. North slopes in the northern hemisphere tend to be cooler, and the sun doesn't shine on them as directly, and therefore there's a little more available moisture there. It doesn't evaporate and dry out as fast as it does on the south slope. And so sometimes we have different species grow on the north slope, or they just grow thicker or more productive. And some people say, well, doesn't that make it two different sites then? Technically, maybe so, but from a practical standpoint, we can't separate out everything, so we just say, well, there's some variability within this site. And so we can see that in this kind of topography, where you have a sort of an alternating pattern of, let's say, more juniper on the north slope and less of it on the south slope and so on. But that's just a variability within the site. Okay, well, this site we're on now is a loamy upland site. It's in the 12 to 16 inch precipitation zone, but it's near the bottom end of that zone. I'm going to say it's probably close to the 12-inch line. We're down at about 3,500 feet elevation and probably on the lower end of that zone. So it hasn't got quite the potential that it would have at a higher elevation. This site is found on alluvium. It's an old surface. It's been here a long time. It's weathered. We have a fairly deep soil that's developed as a result of that. There would be a calcium carbonate layer, but it'd be at more than 20 inches depth. The soil is not limey at the surface. It has a little bit of a reddish color to it. It's loamy or sandy loam right at the surface, and has a good strong B horizon under it. Now, according to the site description, and every one of these sites has a full description that lists everything we know about that site, where it occurs, what its origin is, the soils, the climate, a list of the vegetation that we think was here, let's say, before it was settled. It's not exactly that, but under more or less natural conditions or pristine conditions, that vegetation is described. It was presumably had about 85% of the annual production was in grasses, mainly warm season grasses like you see here. We still got a good grass stand in here, but the shrubs and cactus, mesquite, prickly pear, some cholla, have all increased considerably over what we think it used to be. Now, there's several reasons for that. One is probably that this area was heavily grazed for many years. Back in the early days, Tucson was settled way back there a couple hundred years ago, and there's been grazing in here ever since. It was widely uncontrolled grazing, and so the grazing pressure here in the past was probably very heavy, and that may have reduced the vigor of these perennial grasses and allowed some of the shrubs to increase. Some people think, and I agree with them, that that wasn't the only reason, or maybe not even the major reason, but that we think that before this area was settled and grazed and people deliberately tried to keep fires out of it or reduce the fuel, that these rangelands burnt off periodically. Either the Indians set the fires or lightning did or something. And when they did, they killed out a lot of this cactus and brush and kind of kept it more open. So, and it could be even that extreme drought conditions had some effect on it. But whatever the reason, it has changed from what it used to be. There's nothing necessarily wrong with what's here now. It's just different from what it used to be. And so if we're managing, one of the values of these site descriptions or classifying these sites is to say, well, we are pretty sure that in times past there was a lot more grass here than maybe there is now, and we would like to get it that way again. What are we going to have to do it? If we want it, we have to get rid of the shrubs, or at least reduce them somehow. We probably can't do that with fire very effectively now, but we could do it with mechanical or herbicidal treatments. For wildlife, it may be desirable not to have all grass. Some species of wildlife like to have the shrubs around, either because they eat the seeds, or they nest in the branches, or they hide out underneath the cover of it. From a watershed standpoint, we know that this site is very susceptible to erosion if we reduce the grass cover sufficiently. And if we get too much brush, it's going to reduce that grass cover. When we get up to about 30% canopy cover or so on the mesquite, we probably can't grow enough grass on this site to protect it from excessive erosion. And so we would want to do some brush thinning or brush control just to protect the soil from erosion. So the point is that any site, this one or most others, have several different kinds of vegetation that they can produce depending on how we manage it and what kind of influences are brought to bear there. And what we do by classifying the sites is learn to understand what those different options are and what it takes to go from one to the other. And therefore we can use the site map or the site information as a basis for setting objectives and deciding how we're going to manage that land to achieve those objectives. And then of course we also use them when we're doing range inventories and monitoring, in that one of the basic things we inventory on a ranch is what sites are there, how much is there, and what condition it is in. In other words, how much grass is there on it, how much brush. So then we can set some objectives for that ranch to say, well, we've got a big area of loamy upland site over here that we need to do some brush control on, or we've got an area over here that we haven't got as many shrubs as we'd like, so let's avoid burning that and maybe grow some more shrubs to give cover for wildlife or something like that. So, and then when we monitor, we use these, we do our monitoring on a specific site, because that gives us a basis for interpreting what kind of changes we see or don't see as a result of management. If we spread our monitoring out over several sites, we really don't have any basis for interpreting what the results are. We don't have any ecological site maps online, or not very many anyway, but we do have soil survey reports and soil survey online. Now this is an example of the old soil surveys, the printed type that we used to have, where you have a detailed description of all the soils in it and about 60 of these maps. To take this to the field is pretty cumbersome. You've got maps out flopping in the wind and you have to look through and find out what map it is. But this is a way we could verify what soil we're on in the field. Now, modern technology has improved on that. We've got these little iPhones, and there's an app there that you can just call up the National Soil Survey, and if there's one there, you can see, it'll tell you what soil mapping unit you're standing on and what ecological site that's correlated with. So this is a really neat thing. It's a lot easier to carry this than it is this. The catch is you've got to have a phone signal. Some places don't. A lot of rangeland has little or no phone service, so you may still have to use the printed surveys in some cases. They are online, however. If you have a computer you can use in the field or print it out yourself, you can get all this information online. In fact, they're getting to where they're hard to find the printed copies anymore. You can do it on the iPad as well. And the advantage there, of course, you can also have other kinds of maps, and some of them you can draw lines on and all this kind of stuff. Now, one word of caution. You need to understand what that when they identify a mapping unit and they say that this is a complex, let's say, of for example, Tombstone and Bernardino soil. Those are correlated with the limey slopes and the loamy upland ecological sites. And it'll tell you the approximate percentages of each. If we use, if you generate a map like the NRCS does, or the BLM, with a computer, they use this soils map and they generate an ecological site map. But what that computer generally does is take one of those soil series and project that over the whole area. In other words, they would say it's all loamy upland or all limey slopes, when in fact it's not. And so you've got to be careful of that. I guess the bottom line is this: however you decide, you have got to decide on the ground that you really are on the site you think you are, because the maps just tell you that that site's in that area, and they don't tell you specifically the exact spot you're standing on. So you've got to know how to sit there and look at the soil, look at the vegetation, and maybe dig a hole and figure out, yes, I am in fact on the loamy upland site where I'm going to put this transect or where I'm going to make these observations.